Now, geometry review. We have question 1 here. It says identify the figure as a line, a ray, a line segment, or an angle. And then I want you to name the figure using the given points. So we notice that we have an array here. Array is a part of a line with one end point that extends indefinitely. So if you notice right here is an arrow, so that means it's continuously going on, but this other end is fixed. It's not going any further. So we have an array. And apologize, my writing is just a little sloppy. Okay, so now if we name it, we know that we have C, D, and the arrow is going in this direction. So my name is CD with this vector on top, or a form. Okay. So we do example 2. Example 2 says, use the figure to the right here to find the value of PT. So if you notice, I have a line here, and on each end of that line is arrows. So we know it's continuously going on each end. And in the middle, we have T. On each end, we have P and we have Q. And the question asks us to find PT. And if you notice, P to T is halfway point. So we have a midpoint going on. So we're going to solve for this. And in order to solve for this, I'm going to take my PT, which is 4x plus 8, set it equal to my TQ, 6x minus 4, and let's solve for x. When I solve for x, because again, what do you know that the question asks for PT? It's a halfway point, so we know we get the whole point when we have these two equations. Okay, so I'm going to solve for x. What I'm going to do is get x all on one side and the constants on the other. I like for my variables to be the left-hand side. You could do either way. So what I'm going to do is I'm going to subtract the 6x. And I'm going to subtract the 8. What happens when I do that? The 6 goes to 0 and the 8 goes to 0 and leaves me with x values on one side and constants on the other. So I have 4x minus 6x. So that's basically saying you have $4, but you spent 6. Now you're in the hole $2. Now on this other side, we have a -4 minus 8. So it's like you're in the hole $4, but you turned around and spent 8 more. So now you're in the hole -12. We're going to divide by this -2 because we want a +1 coefficient on my x. Negative divides negative becomes a positive. 2 goes into 2 one time, leaves me with +1 on x. Then I got to divide it by this other side. Negative divides negative is a positive. 2 goes into 12 6 times. Okay, so I know what my x value is for the whole entire line. I just don't know what PT is. And to find PT, I'm going to take its equation that was given, and we're going to plug in for x. So now I have 4 times 6 is 24, and we're going to add 8, and that gives me 32. So now I have my answer. Okay. So if I go too fast, just let me know. I'll slow down. Example 3 says name the angle in 3 different ways. So you see that we have this angle going on here, and we have H, G, and I, and we want to name it. So an angle is formed here. We have 2 arrays because it has an end point here, a fixed point, and at the end of each arrow has or at the end of each line has an arrow, so we know it goes on continuously. So I know I have 2 arrays here. The arrays of these sides ends up with an endpoint. We're going to call the endpoint here where H is at my vertex. Since an angle can be named using only the name of its vertex, the particular angle could be called, and this is a sign of measurement, h, the measure of h. An angle can also be named using the point on each ray and the vertex. Okay, so we know that we have this h and g and I, right? So I can go from g to h to I. So I have a measure that goes g, h, I. And then we can come around this other way, right? Go back this way. So I have a measure of I, h, g. And there's 3 different ways to name this. Okay. So number 4 says, I want you to classify these angles. And the reason why I want to do this here is just because I want you to get a better understanding of what these mean. So whenever I talk about an angle that's straight, that means, what do we have here? Find my mouse. There it is. We have a straight line. It could be written vertically, right? Horizontally here. It could be written at an angle, but it's a straight line. You agree? Well, a straight line means that we have 180 degrees. Acute is an angle like what we had up here that has 2 arrays attached to an endpoint. Gives me a vertex, right? But this angle here is going to be greater than 0 degrees, but less than 90 degrees. That is called an acute angle. An obtuse angle, again, has 2 arrays connected by an endpoint, a vertex, but its angle is actually greater than 90 degrees, but less than 180 degrees. A right angle, this one here is real common and most people knows it. We talk a lot about it in college algebra and other math classes. Has a 90-degree angle. That's a right angle. Okay. Example 5 says we have a measure of RQT is a straight angle. What is the measure of RQS and the measure of TQS? So if y'all can see this, I got R and I got Q and I got T and I got S, and now I want to solve for each one, this end part here. All right, so let's do this. So what do I know? I know that I have this parentheses here. It tells me from R to Q, which is a halfway point, right? We have 11x plus 4. We're going to add that to, and I'm going to put it in parentheses because if we was to subtract, that negative sign would change everything, but we're going to add. And then we're going to add it to the other half, which is 8x plus 5. And since it's a straight line, we're going to set it equal to 180 degrees. Okay, I'm going to drop the parentheses because nothing's outside of it's going to change anything inside of it. And I'm going to combine all like terms. So we have 11x plus 8x is 19x. I have 4 plus 5 is 9. And I need the x variable by itself. So what I'm going to do is I'm going to subtract the 9 from both sides. And when I do that, I get 19x is equal to 171 degrees. And we could drop that degree sign while we're doing this. Now I'm going to solve for x. To solve for x, I need to get it a positive 1 coefficient. If you notice, it has 19. So we're going to divide by 19. 19 goes into 171 9 times. So I know what x is. Now let's figure out what is the measure of RQS. Well, to do that, when you go back up here and look at this image, you know that that is going to be RQS. That's going to be 11x plus 4. Well, we know what x is, so let's plug in. So 11 times 9 plus 4. So 11 times 9 is 99. Then we're going to add 4. We get 103 degrees. So we know that measure. The next one says find the measure of TQS. Well, we look over here and what do we see? We got 8x plus 5, and let's plug in for x. So 8 times 9 is 72. We're going to add on 5, and that gives me 77 degrees. And that's all there is to those. Okay. Number 6. So it says in this figure here to the right, actually I moved it down. I was going to put it to the right, but it kind of messed up all that typing and it kept wanting to space everything. So I just put it down here underneath it. But if you'll notice, we got S/T. So what is this telling me? We have 2 lines here. One is called S and the other one's called T. It says use the figure to answer the following exercise. We want to know the measure of E. Well, here's E. That's equal to 2 of the following angles. So let's do this. So vertical angles, corresponding angles, and alternate interior angles all have the same measure. So these here, we have these 2 lines that are running parallel to each other. Vertical angles are opposite each other, formed when 2 lines intersect. So this figure here shows me that we have E, the measure of E here. And then right across from it, we have measure A. So those 2 are going to be the same. So I have E, measure of E, and a measure of A. So what we'd say, A is vertical to the measure of E. Now the alternate interior angles are formed when 2 parallel lines are cut by the transversal. So the 2 angles that are the opposite sides of the transversal and between the other 2 lines are alternate interior angles. In the figure above here, we're going to have no labeled angles is alternate. So there is nothing alternate to this E here because it's not above it, right? Okay, so corresponding angles are formed when 2 parallel lines are cut by the transversal. So the 2 angles that are on the same side of the transversal and are both above or below the other 2 lines are called the corresponding angles. In this figure here, we see the corresponding angle to the measure of E is measure of D. So the measure of D is corresponding to the measure of E. Okay, remember we were focused on E. Okay, so therefore, what do I know? Therefore, the measure of E is equal to the measure of A and the measure of D. All right. We got some more to go. Okay, so number 7 says find the measure of the supplement of 117 degree angle. Now remember the 2 angles are supplementary. If and only if the sum of their measures is 180 degrees. Well, knowing that, I can take 180 degrees, subtract that 117 degrees, and I'm going to end up with 63 degrees. And that will give me my other angle that's supplementary to it. And that was just that easy. All right. Now let's do example 8. So example 8 says find the distance between the 2 points and the midpoint of the line segment. So we got some math to do here. Let's give me some space here. I'm gonna write a little big. All right, so we're gonna first, let's find the distance. Well, the distance formula is going to be x2 or x subscript 2 minus x subscript 1 squared plus the y subscript 2 minus y subscript 1 all squared. And let me talk about where I get x subscript and 2 and x subscript 1. What that tells me is this x subscript 2 came from the second order pair. So we know order pairs is x comma y. And if you notice here, we have 2 order pairs. So the first order pair, I'm going to put a subscript of 1 on my variables. And on the second order pair, I'm going to put a subscript of 2 on it. So I can decipher the difference between the y's and the x values from each order pair. And let's plug it in. So 23 is my x value from the second order pair, minus the x value from the first order pair. What's a -4? So I'm going to put it in parentheses because what happens, negative times negative becomes positive. So now I got my y value from the second order pair, which is a -127, subtract the y value from the first order pair, which is -7, put it in parentheses because we're going to clean it up right here on this next step. I got 23, this negative times that negative became a positive. My -127, this negative and this negative becomes a positive. And now let's clean it up some more. We have 23 plus 4 is 27, and we got to square it. I have a negative 127 plus 7. I'm going to put that back in parentheses because it's like saying all you had was $7 and you spent 127. So now we're still in the hole. Now let's square it. Well, 27 squared is 729. Let's talk about squaring this 120. Remember, the 120 has a negative sign. So when I square that negative, it becomes positive because it's the same as saying negative times negative an even amount of times, which becomes back positive. So 120 squared is 14,400. Now we got 729 plus that 14,400 gives me 15,129. And now let's take the square root and I get 123. So that's my distance between these 2 order pairs on the graph. So let's find the midpoint. The midpoint formula, and it's a capital M, it's going to be my x from the first order pair plus my x from the second order pair divided by 2. And I'm going to put a comma here because this is going to give me my new order pair. It's going to give me my halfway point between the 2 order pairs here that were given to us at the beginning. Then we got y from the first order pair plus y from the second order pair, all divided by 2. And let's plug in what we know. My x value from the first order pair is -4 plus my x value from the second order pair. And if you want to go ahead and do the math here, and then, you know, it depends on how many steps you want to make, but 23 minus the 4 gives me the 19 halves. I'm going to put a comma here. You don't have to write it this way. Like I said, if you want to add another step, you could have. So my y value from the first order pair is -7 plus my y value from the second order pair, all squared. So I have a negative plus a negative. That means it's going to end up being what, a positive. I mean, it's still negative, but we're going to add them together is what I meant to say. So it gives me a -134 divided by 2. And then I'm going to just rewrite this a little bit neater. So I have 19 halves because if I reduce it down, it's going to be fraction form. So we'll do that here in a minute. 134 actually reduces down nice and pretty to negative 67. So be sure and read if it wants you to write it in decimal form or fraction form. Either one of these would be correct, depending on how the directions state to answer it. Okay, so that was solving for midpoint and distance. Okay, we got one more from this part. I wanted to talk a little bit about the origin, an arc, an angle, and a vertex, just a little bit. Some of you just may need a refresher, some of you don't. You may remember it. The origin is the initial point or starting point where we begin our calculations or measurements. And I like to think about the origin was when I look at a graph. The origin is the center part here that's order paired 0, 0. Whenever we plot x comma y on the graph, we always start here at the origin. So that's what it's saying. It's saying it's where we initially start. The arc is a portion of the circumference. So I'm gonna try to draw a circle here. So the arc would be like some portion of the circumference. An angle, well, we just talked about a bunch of angles. They could be arrays, they could be straight lines with a point added on, which gives us 2 arrays, right? Okay, a vertex is where they meet at. The most common vertex people solve for is in college algebra is gonna be like on parabolas, you know. So